In this video, we will learn how to find trigonometric ratios for angles greater than 90 degrees. Whenever this angle is greater than 90 degrees, we represent them sometimes as 180 minus theta, sometimes as 180 plus theta. However, most of the times I've noticed that the students tend to memorize these formulae and then use it, but with very less understanding of what it actually means. So this video is to help you to lay a good foundation. So even as you progress in your career, this will give you a good perspective to many applications that you will actually use this values. So let's proceed. Let's consider this right angle triangle inside a unit circle, and at point P the triangle touches the circle. The coordinate of the point P can be written as x and y if OM equals to x, which is on the x-axis, and PM is equal to y, which lies on the y-axis. So if I'm going to move this point P further up towards the y-axis or on the circle, keeping the same radius, let's consider this radius to be 1 here. And if I move it up, let's see what happens. So when I move it up, you see that this length keeps increasing and this length keeps decreasing. As it moves up, this is decreasing and this is increasing. And also you will notice this theta goes short, but then it's become bigger and bigger. The angle is getting bigger. If I move it all the way here, then you will notice that our theta is almost now 90 degrees. So as theta approaches to 90 degrees, we notice that this OM is getting close to coinciding with each other, which means M will disappear into O and P will coincide with the y-axis. But if I'm going to move this point P further into the negative side, notice our OM was becoming smaller and smaller. You can notice from here it was getting smaller and smaller and smaller, but when I push it to the other side, we're going to make it become negative. Okay, so we're going to assume a negative x here. How is this? So what is this application? Our theta is outside the triangle and we are trying to find the trigonometric ratio for this theta here, and our triangle is now outside the angle. Alright, so what does this mean? So this is where I want your full attention. We're going to take some time to understand this concept. Now consider this young man who is playing basketball, and if we place a mirror on the y-axis and he is on the first quadrant, right? So if you place a mirror here, you will see his reflection on the mirror and you will see this image, right? Now his shoulder height will be exactly the same in the mirror as it is in the real world, right? So they will be on the y-axis. So if you're going to draw a straight line here, they will be in the straight line. But you will notice that this point here, the shoulder, it touches the x-axis at this point, but the same shoulder here touches the x-axis at this point. Even though they will be equidistant, this will be negative x and this will be positive x. This is the reason y we have a reflection on the other side, or in other words, we are describing the reflection by a negative value. So similarly, this triangle is nothing but a reflection of another triangle on the first quadrant. If I'm going to reflect his image on in the x-axis, so which means he will come, his reflection will be downwards. So you will notice the reflection is now downwards, and his height will be the same, but it will be in the negative. It will be on the y-axis on the negative side. So let's find the image that will cause this mirror image on the first quadrant. So I'm going to take this particular triangle. So let's assume that this is our theta and this is our mirror image triangle that we have formed, and our objective is to find the trigonometric ratios for this theta, which is about 90 degrees. So this triangle is the mirror image of this triangle here. And also you will notice, because it's a mirror image on the second quadrant, the y value is the same. So this height will be y, and this height also will be y. However, on the x-axis it will be positive here, but it will be negative here. So if it is positive here, so we can write this coordinate as x and y. So that's our coordinate x, y. And we can write this coordinate here as minus x and y. Great. So this is the mirror reflection of this image on the first quadrant. Great. Let's now try and find the trigonometric ratios for this triangle, the original triangle. So sine theta is equal to the opposite side, which is y, over the hypotenuse. We are going to consider the hypotenuse, which is the radius of the circle, to be 1. Okay, so it's y over 1. So you get y as your sine theta, and your cos theta is adjacent side, which is x over 1. So you get x over 1, which is x. So we can rewrite our coordinates by substituting the value of x and y with cos theta and sine theta. So our new coordinate is cos theta, sine theta. Right. Similarly, we can write for p dash its coordinate as theta 1. We're going to call this theta here as theta 1, and cos theta 1, sine theta 1 will be its coordinate. Great. So cos theta 1 is going to be equal to minus x, and sine theta 1 is going to be equal to y. So further applying, let's say that sine theta, sine 180 minus theta, which is the sine theta 1, is equal to y. You can see that here, right? Sine theta 1 is equal to y. And we also know that y is sine theta. So you notice sine 180 minus theta is equal to sine theta 1, which is equal to this y here, and it's also equal to the sine theta. Right? So we have derived that sine 180 minus theta is equal to sine theta. Similarly, if we apply the same for cos 180 minus theta, so we have cos 180 minus theta, which is cos theta 1 here, and that is equal to minus x, and this x is nothing but cos theta. So substituting the value of x here, you get minus cos theta. Alright, now let's move on to find what will happen to our tan 180 minus theta. So tan 180 minus theta is equal to sine 180 minus theta by cos 180 minus theta. And we know from here that sine 180 minus theta is sine theta. So we substitute the value here. And cos 180 minus theta is minus sine cos theta. And we apply the value here. So we get our result as minus tan theta. So that's, to summarize, sine 180 minus theta is equal to sine theta. Cos 180 minus theta is equal to minus cos theta. And tan 180 minus theta is equal to minus tan theta. Hope you enjoyed this video. To see more of these videos, kindly subscribe. And also, if you have any comments, please, you can drop it at the comment box. And if you have any specific videos that you would like me to make, you can also mention that. Thank you for watching.